Number 3, last year a business earned 4.1 times 10 to the 6th dollars in income. This year the business earned 2.05 times 10 to the 8th dollars in income. Which best describes how this year's earnings compare to last year's earnings? They just want us to compare the two, and we're going to decide. You can see that all of these say times as much, which means we're going to be dividing. Now remember, when we want to know times as much, we're going to divide the big number by the little number. We're going to have to decide which number is the bigger number. 4.1 times 10 to the 6th versus 2.05 times 10 to the 8th. When scientific notation is correct, you can compare your base 10s, and the larger base 10 is your largest number. 10 to the 8th is 2 place values larger than 10 to the 6th, so we're going to put it on top. 2.05 times 10 to the 8th, and we want to divide that by 4.10 times 10 to the 6th. Now, since they said best describes, they mean that we can approximate this a little bit. 2 divided by 4 would give me 0.5. And then when I divided my base 10s, I've got 10 to the 8th minus 6, which gives me 10 squared. When I don't jump to conclusions, it's not 0.5 times, okay? We have to move this 2 decimal places bigger to get 50 times. This year, the business earned 50 times as much as it did last year. Number 4. I think out of the whole study guide, this is probably the hardest question because it's got negative exponents and it's got negative numbers in it, so you had to be really super careful on this one. We've got these two in scientific notation and these two are in standard form. You can swap them all to the same form. You can either go all standard or you can go all scientific. In scientific notation, this one is negative 2 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. And this one is positive 7 times 10 to the negative 1, 2, 3, 4, 5. Now, you need to notice and remember that just because a negative exponent is given, that does not make the number negative. The number is either negative or positive on its own. The exponent just tells you whether it's less than 1 or greater than 1. Now, if you prefer standard form, you could have changed these and you would have had 1, 2, 3, 4, 5, 6 for that one. And for this one, you would have had negative 0.009. Now, your two negative numbers have to be smaller, so we could at least get it halfway right. Our two negative numbers are going to go here, and our two positive numbers are going to go over here. Negative 2 times 10 to the negative 7 versus negative 9 times 10 to the negative 3. Now, on a number line, the closer the number is to 0, the bigger it is, okay, when we're talking about negatives. This number is going to be closer to 0, okay? It does have the higher exponent, but because it is negative and it's less than 1, this is such a tiny number, it is definitely the least. So negative 2 times 10 to the negative 7. Probably should have put it in standard form. 1, 2, 3, 4, 5, 6, 7. And then that leaves the other negative number, negative 9 times 10 to the negative 3. Now we've got 0.00005 and 0.00007. This one has an extra decimal place, which makes it smaller than the other. You could also look at those exponents. And that should have been the correct answer on that one. Okay, hang on just a second. Can't get my mouse to cooperate. Okay, guys, I've got these backwards. Because these are negative numbers, the larger number is actually the farthest number from 0, which makes it the smallest number. So these two need to be switched. Okay, the negative 9 times 10 to the negative 3 goes first. And then the negative 2 times 10 to the negative 7. All right, on the back. Number 4. Which of the following numbers is not in scientific notation? It is C. And the reason is because that number is less than 1. It's 0.21. It is not in proper form. Number 5 says to write this number in scientific notation. Explain how you found your answer. We are going to move the decimal to make it 3.105. And then we're going to count our place values to get our exponent. Our exponent will be negative because the number is less than 1. 1, 2, 3, 4, 5, 6, 7 decimal places, and this is the answer. Now, I'm not going to write down the explanation because I just told you. Which of the following expressions is equivalent to 4,325,000,000? It cannot be a negative exponent, so it can't be A or B because this number is greater than 1. It's going to be 4.325 because we have to move the decimal. Then we count our base 10s, 3, 6, 9. It is D. Carson chose A. Carson used the wrong exponent. He gave it a negative. He gave the exponent a negative, and it should have been positive because it was greater than 1. Number 2, the mass of Earth's moon is about 7 times 10 to the 22 kilograms. The mass of Jupiter is about 1.89 times 10 to the 27 kilograms. The mass of Jupiter is about how many times the mass of Earth's moon? Now, they tell you which number is larger in the problem. They tell you which one to put on top. The mass of Jupiter is how many times the mass of Earth's moon. So they're telling you that Jupiter is the larger number. We want Jupiter over the moon. Jupiter is 1.89 times 10 to the 27. Divide that by 7 times 10 to the 22. 1.89 divided by 7 gives me, don't feel good about that number, I'm going to check it again. 1.89 divided by 7. 0.27. And then I subtract my exponents using the quotient rule to get 10 to the 5th. This is not in proper scientific notation. If I increase my number by 1 place value, I decrease my exponent by 1, giving me 2.7 times 10 to the 4th. Now, in standard form, that would tell us that it was 2,700 times the size of the moon. Lesson 5 is scientific notation operations. These are the ones that you're going to have to be able to decide, do I add, do I subtract, do I multiply, do I divide? We'll tell you that the test is very heavy in scientific notation. It covers everything, but there is a lot of scientific notation on there. Number 1 says a rancher uses a water bowl for her dog that holds 8,500 milliliters and a water trough for her horse. That's 2.7 times 10 to the 5th milliliters. How many milliliters of water will the rancher use to fill both the bowl and the trough? This is a combined amount. We have a water trough and a dog water bowl, and he wants to fill them both. Okay? We are going to add, because when we combine things, we are adding. Now, the first step would be to take 8,500 and put it in scientific notation, which has been done correct here. Now, to add those, we've got 2.7 times 10 to the 5th, and we want to add 8.5 times 10 to the 3rd. We cannot add these until they are in matching scientific form, meaning that their base 10s have to be the same. I'm going to increase the 3 2 more places to make it 5. When I increase my exponent, I decrease my constant, giving me 0.085. So 2.7 plus 0.085 gives me 2.785. And then I keep the base 10 the same. They do not combine. And I get B as my answer. Number 2. The moon takes 28 days to orbit the Earth, going a distance of about 2.43 times 10 to the 6th kilometers. How many kilometers does the moon travel during one day of its orbit around the Earth? So, bless you. They want to know the distance per day. Okay, they want to know the distance per day, which means we need to set up our problem with the distance on top and the days on bottom. They've not given us a per day rate. They've given us a per 28-day rate. So our distance was 2.413 times 10 to the 6th. We want to divide that by 28. Now, 28 is not in scientific notation, so I'm going to fix that. I'm going to move my decimal, making that number 1 decimal place smaller, so my base 10 needs to have 1 exponent to represent that. Now I can divide 2.413 divided by 2.8 gives me 0.86 and a bunch of other numbers that we're going to ignore. And 10 to the 6th divided by 10 to the 1 is a quotient rule, so we subtract to get 10 to the 5th. Then we move our decimal place. I'm going to increase 0.86 to 8.6, which means I need to decrease my exponent, giving me 8.6 times 10, not to the 6th, to the 4th. And it is A. And that one is A. Number 3, Jackie incorrectly simplified the following expression. Select each step that shows an error based solely on the previous step. Now, here's the original problem. Step 1, the first part's the same, the second part's the same. The third time, they've put into a partial scientific notation. 1,000 is equal to 10 to the third, but that is not in scientific notation to match the problem. So I'm going to mark this one as incorrect because I really feel like they should have said 1 times 10 to the third. Okay, if you're going to go scientific notation all the way. Okay? Pick a one and go with it. Now, step 2, we're looking to see what's happened. 4 times 10 to the 6 is the same, but this number is not. So how did they get that? They said 2 times 10 to the third plus 1 times 10 to the third, and they got 3 times 10 to the third. That is not correct either, because are we allowed to add before we multiply? We are not, so that is incorrect as well. They should have multiplied first. They should have had 4 times 2 is 8 times 10 to the negative 6 plus 3 is negative 3. And then they should have had the plus 1 times 10 to the third. So that step was incorrect as well. Now in C, they've said 4 times 3. They took their constants and multiplied them together. And then they combined their base 10s. If they had done step B correctly, this would possibly be correct because the process is correct. They just did it wrong because step B was wrong. Now, based solely on the previous step, this one is correct. It's still wrong, okay? It's not correct. It's just they did the right math. It should have been, like, they couldn't do that at all. They should have been working on making these the same base 10, which they didn't. So we're going to ignore the right answer and we're just going to focus on their work. They said 4 times 3 is 12, 10 to the negative 6 times 3 is 10 to the negative 3. That is, 4 times 3 is 12, negative 3. That's correct based on this step. And then 1.2 times 10 to the negative 4, they moved their decimal. That's okay. A decrease here should have been an increase here. They should have had a negative 2 there. They should have had 1.2 times 10 to the negative 2. Okay, they didn't ask us to find the right answer. They just asked us to decide if he was correct as he went through the problem. Okay, he was wrong here and here, then he was okay, except his answer was wrong.